Okay. Actually, good evening. Hello. My voice is clear now. Hello. My voice is audible now.
Yes, yes.
Yeah. Thank you. Okay. Actually, in previous session, we come across with the design using Verilog. So in this session, we will go through with our verification part. Okay. Actually, it is big only, but conceptually it is easy because we know the our verification architecture, no UVM verification architecture. So while comparing to it, it is easy only. Okay. So while understanding conceptually, it will be easy, and somehow coding is big only. Okay, because we use two components each. Like when it comes to sequencer, we use a sequencer for reading and we use a sequencer for writing. Why in the sense? Obviously, our we have one source, three destinations. No, so our source will send. That is, it is going to write. So we are going to form a write sequence. Okay, and our destination will read, okay, that packet. So we are going to form a read sequence. Like that, for every component we will create two for each component, okay, for write and read. Okay, so we will have a virtual sequence and virtual sequencer, and then we will have agent. Okay, agent in the sense, yeah, we have a agent. And here, since we may have uh, more than three transactions. That is, how can I say, means there is a sequence, no? So we may have more than one sequence because we have three destinations. Okay. So for three destinations, they will expect, sometimes they will expect three different transactions. Okay. So each destination may expect different transactions. So we need different sequence. So for the we need to create separate agents. Okay. So we will use dynamic array concept here. Actually, conceptually it is easy only. Okay. So uh, I will tell you how the logic works like that, and I think coding. Do you received that EDA playground coding for this project? Codings are received or not yet received? Anyone? Not yet received? The coding for router. Hello. You can. It is difficult to unmute. You can comment, no? That also I'm available, but better unmute and speak. No problem. Codings received, no? Hello?
Need to check like don't mention GitHub link if doesn't then need to not check.
Okay, okay. You need to check whether that coding is received or not, right?
Like one GitHub link is there. There all the things are present. So after the project is present on that one, I need to check.
Okay, okay. Okay then. Okay. That is what I'm telling. I think they have shared, but okay. I will if it is not shared, I will tell them to share. So you can go through that coding. Now I will teach the logics, and you should go through that coding. Then only you come to know like what is the actual logic and see uh, how more than logic. Okay, more than logic, there are some procedures here. Okay, so before doing this logic, we need to follow some procedure like that. Here, there are some procedures. Okay, so if you come across that code once again, then you come to know, okay, these are the procedures and the logic we used here is a particular logic, this one. Like that, you will come to know. Okay, so for that purpose, I am telling. Okay, now I can tell you, okay, this is the logic. This is why they have used this block. And here is that exact meaning of this block. Like that, I can tell you. But the remaining, that standardized way they have implemented, no, that and all you need to go through once. Then only you can understand fully. Okay. Even once again, I'm telling, in a single go, no one can understand. Okay. Yeah, we can understand, but not full percent. Okay, we can understand some logic and some blocks, why it is used here. We can understand like that, but for complete understanding, we need to go through it for 2 to 3 times, or it based on your capacity. Okay, So okay, we will go to the verification part. Wait, I will share my screen briefly. Okay, my screen is visible now. Hello, my screen is visible now.
Yes.
Okay, thank you. Okay then. See, wait, I will increase the font size. There are some procedures now. Okay. Actually, once again, go to the design part. Okay, you can go through the design part, and I think the recorded sessions are sent. So you can go through that once, and then you come to this verification while reference for your reference. Okay. Uh, Once again, you go through. No, for that I'm telling. Okay. Okay. See, first of all, I will explain. Okay, what are the blocks and why it is for. Then we can go into separate blocks. Okay. See here. This is test bench, we all know. Okay, no problem. Wait, I will explain even though. Wait, one by one I will explain. First thing is we need to search for transaction. Okay. See here, transaction. So transaction in the sense it is going to have what are the inputs and what are the outputs. What we are going to transact. Okay. So what we are going to transmit. That members know what we are going to transmit, what are the inputs, what data we are going to transmit. That that information will be there in the transaction block. Okay. So there are two different transactions. As I told you before, here we are going to implement two components. For each component, we are going to implement two. One is for write and one is for read. Okay. So here is for write transaction, and yeah, same transaction means whatever going to involve the inputs, whatever the data going to involve in the transaction will comes under this transaction. Okay, this particular block, that is UVM sequence item. Okay, so here there are two blocks, one is read and one is write. So after that we will have sequence. Okay, so sequence in the sense in UVM sequence is going to generate the transactions. Okay, so for write transfers, that is for sequence item which is of write. Okay, for that we have particular different separate transaction. Okay, for that we have separate sequence, and for read we have separate sequence. Okay, see, it is read sequence, and then after sequence we will go to sequencer. Okay, where it is, yeah, clear. See, actually, sequencer is a small block. Why in the sense here in this uh, constructor, no? So inside the constructor, see, we are using super.new. What it means? It is going to extract the methods and the uh, class members from the parent class. Who is the parent class? From UVM sequencer. Okay. So we no need to write the logic. If we have some extra logic, if we need to customize, we can. But in this place, we no need to do that. Okay. As usual, as I told you, we need to follow some procedure. So in order to follow the procedure, we have this block. So we are following some procedure of course, so that this sequencer will act as a mediator and a control between our transaction and our that is our sequence and our driver. Okay. So there is a sequencer, there is a sequence, and there is a driver. Okay. Sequence is going to generate the transactions and driver is going to receive the transactions. Okay. So someone in between need know to get that transaction from the sequence and to give the transaction to the driver. We need some mediator, that is sequencer. Okay. And we need some control, because in our case we may have two transactions, three transactions, we may have two sequence, three sequence, like that. So each sequence may generate different transactions. Okay, so in that case we need a control. Okay, so our sequence will control for this time this transaction should be passed. Now it is in a or some other transaction is on the way. Okay, so our sequence will hold the signal, hold the permission for the sequence. Okay, for the particular sequence. Like that, we have some control for that sequencer. That is why we are using sequencer. Okay, for controlling the transaction. At the same time, there is a mediator to get the transaction and to give to driver. From sequence to driver to make a handshaking, we use sequencer. Okay. Okay. See here also we have write sequencer and there is read sequencer. Actually, the blocks are somehow unaligned. So, okay, I will explain anyhow. So then after sequencer, obviously we have driver. Okay. So where to see? Here we have read driver. Driver in the sense we all know it will get the transaction from the sequence through sequencer and it will send the transaction to DUT. Okay. So DUT will process the transaction. So as of now, we have two drivers. One is read driver and another one is write driver. Okay. So after receiving that, see, and you should notice one thing. Okay. When we go deep into the code, we will discuss. But anyhow, see, we are doing configuration here. Okay. So why this configuration is, I will tell you. In the agent, we have some configuration. I will tell you. So after driver, we have monitor. And we all know why monitor is used. Monitor is used for analyzing. It will get the output of the DUT. Okay. So output of the DUT will be received by our monitor. And why it is receiving? For analyzing. It is checking what are the data we are receiving, like that. Okay. And then scoreboard will check. It is separate part. Scoreboard will check the expected data versus the received data. Okay. It will check. As of now, monitor is to analyze. It will get the output from the DUT and it will receive the data for analyzing purpose. Okay. Okay then. Then monitor, as we all know, sequencer, driver, and monitor. These all comes under a agent. Okay. So see here we have two agent. One is read agent and one is where it is write agent. See here one is write agent. Okay. So you have some doubts like why this write agent configuration, read agent configuration. We no need to confuse like that. See write agent configuration in the sense. One second. This screen is open. So my screen is not visible. Huh? Hello.
No, not this one.
Okay. One second. One second. Yes. Where it is? How it is visible or still not visible? Huh?
Still not visible.
Okay, wait. How it is? Suppose. One second. One second, please. It is loading actually. Okay. Now it's visible. Huh? Now it is visible. Huh?
Yes.
Okay. Thank you. Okay. Where I left? Okay. Here. Okay. Um, you can have a question like why we have an agent. Okay. We have a write agent. We have a read agent. Then you have a question like why this write agent configuration? Why this read agent configuration? Like that, you may have some question. See, it is simple. Configuration in the sense we are going to set something for that agent. Okay. So, for example, we may expect our agent to be active and we may pass some data. to our agent. Okay, so for that purpose we are using some configuration separately. Okay, then we will see here we are setting the configuration. Okay, so it is our configuration. Okay, we have our configuration in a separate block. So when you go into the agent, you can see something. See here, they are getting that configuration. Whatever we set in that configuration separately, we will get here. Okay. So what it is uh, for our simplicity and for our easy access. Okay. We need to understand, no. So if we include these configurations here and we make it more complex means while we referring, we need to go to this particular block and we need to search. But if we have a separate block for configuration, we can directly go to the configuration. We can directly check, okay, what are the configurations we given to that agent? Like that, we can check like that. Okay. So this write agent top will have all this configuration, all the agents, and it is, see, uh, let's consider this agent. Okay, this write agent as the block. Okay, it have the all the functionalities, all the characteristics of the agent. Okay, this is different. This configuration is going to act inside this agent. Okay, right now we have one agent. Okay, so as I told you before, we may have more than one agent. Okay, so we need some place where it can have a group of agents, that is called as agent top. Okay, see here, see, they have mentioned the dynamic array. No, what it means, we may have some more than one arrays. Okay, we don't know about that. So that's why they are allocating it dynamically. What is meant by dynamical? Dynamic in nature. It this new space, that memory allocation will happen in the runtime. So we no need to worry about the space. Okay, it will allocate in the runtime itself. Okay, so that's why they are having this write agent top. Okay. Okay, then whatever. Same, similar for read agent. See here, for read agent, we have a particular block. See, once again, I am telling the conceptual, we can understand the conceptually. We can understand conceptually. Okay, it is easy. And we can understand the logic. But inside that, okay, inside that code, we have some procedures and we have some blocks. Okay, that and all. When you are going through, once again, if you go through that code mix, then you can understand. Okay, as of now, I will try to explain the my best. Okay, I will try to explain the best. What I try to explain is, I will explain what are the blocks are, and inside what are the logics are used. Okay, like that I will explain clearly. Okay, then you need to go through. Okay, in that time, if you have any doubt, you can ask me. Okay, so same for read agent, and for read agent we have configuration, and then here read agent top. Okay, see, in write agent configuration, you can see here they have mentioned like 0. So it is count value. Okay, we will discuss why this count value and all. But see, in the read agent configuration, they didn't mention any count value. Why? In the sense, obviously we are going to receive that. So we can uh, in write agent, we have some this many counts, like that. We have some particular count means obviously that count is going to receive by the read agent. So we no need to initialize, it will receive. Okay. So after agent, we have uh, environment. So see, same here. What I told agent, we have an agent. So in order to configure something inside the agent, it will be difficult. And for that, we are using some separate block for configuration. Same for environment, we are using some separate block for configuration. Inside that, there will be some information, how many scoreboards are there, how many agents. See, you no need to confuse with this agent. It is like one. This particular has V agent, it means it has write agent. Okay, it have one write agent. Inside that write agent, we are allocating dynamically. Okay, so it may, based on our requirement, based on our needs, it may allocate more agents. Okay, more than one agent. Okay, as of see, they have mentioned here, no. So it will allocate one write agent, three read agent. Okay, as of now. In future, if we have some update means it will dynamically allocated. Okay. So why one write agent, three read agent means we all know we have one source and three destination. Okay. and we have write agent configuration here. Okay, same only. Okay, so we are configuring our environment here. So we need to see where actually our environment is. It will be in this router TB. See here. Here it is. Okay. See, we are extending from UVM ENV, that is UVM environment. And here we will create like um, we are going to create monitor, driver, like that. Sorry, monitor, driver, and all created an agent. Here we are going to create the agent. See here. WAGT means write agent top. Write agent top in the sense I told you no, we will have a agent block, that is write agent, and we have the configuration which is going to act inside that agent, and we don't know how many agents are there. So if there is more than one agent, we need a particular block which can handle more than one agent. So that's why we are using write agent top, and we are creating that write agent top in this environment. Okay. So here we have virtual sequence and virtual sequencer, and we all know why we are using virtual sequencer in the sense here we are having more than one sequence and sequence and sequencer as well. We have more than one sequencer. So for that we need a place where we can control all the sequences. Okay, all the sequencers. So we are having virtual sequence and virtual sequences where we will have all the sequence, what are all the sequence we have and what are all the sequencers we have. We will have in a particular block called virtual sequencer block, virtual sequence block. Okay, that see here, for example, this is a router virtual sequencer, and here see they are having this one second. Okay, okay, see here, this is a router write sequencer. Okay, we inherited here in the virtual sequencer. Why here it is dynamically allocated? Because we don't know how many sequencer are here, how many sequences here. It may vary. Okay, as of our concept, we are using three destinations. For three destinations, we may have three agent, and for source, we may have one agent. So for each of them, we may have some sequencer. We may have four sequencer like that. I am telling example. Okay, but it may vary. Okay, so for that they are allocating dynamically, and see all this sequencer, all this write sequencer, read sequencer are going to handle by a common sequencer, that is virtual sequencer. So why virtual sequencer means instead of going to that write sequencer, read sequencer separately, we can access here itself in this virtual sequencer. We come and we can see here. Okay, there are these many sequencers like that we can understand. For that we use virtual sequence and virtual sequencer. Okay. Okay.
So,
What?
for
Yeah.
like there is a read sequence separate, there is a write sequence separate, and for those there are the
Mhm.
separate sequencers also, right?
Yeah.
Yeah, and
Yeah.
then there
Mm.
will be a driver also separate so that there is a separate agent only like that you are telling.
Yeah, actually, see here, that is why I'm telling like, see, for example, right now here is a driver for read. That is what
Mm.
router, write for
Right.
router, write
Mm.
driver. And we have some router where it is. mm, See here we have
Okay.
router like that. We have for everything, we have separately. So as you told, okay, we have different sequencer. For write we have different sequencer, for read we have different sequencer, and inside that read agent, if you go into the read agent, as I told, we are having three destinations, so we may have three sequence, so we have three sequencers, it seems. Okay, so at that case we need some common place where we can hold all the sequencer, and we need a
Yeah.
common place where we can hold all this sequence. So that's why we are using virtual sequence and virtual sequencer.
Yes,
But
yes,
as you
yes.
told here, there is for separate read agent we have separately, write agent we have separately like that only.
Okay. So
Okay.
monitors are also different, right?
Yeah, everything will be.
So there are
Only our,
two
yeah,
agents, you can say,
yeah,
right, here.
everything, for write and read, we have separate agent. So inside
Okay.
that read, we may have three agents. Inside that read agent, see, it is a read agent. So
Yes, yes,
that
yes.
read agent, there is, since I am telling no, there will be three destinations. So for that, we may have three agents inside that read agent. That is what this read agent job. Okay, that is why they are allocating in the seventh line. They are allocating this read agent as dynamic because we may have three agent, and we will see in the code when we go into that. See here. Here they are using for each and read agent. What is the TH means? It is first and second. It is third, fifth, like that. Okay. So there may be like more than three agents, more than four read agents. So there should be a place where all read agents should be present in a place. That is called this read agent top. Like that, there will be separate for read and write. Everything will be common in one place, that is our environment, and every sequencer will be in one common place, that is virtual sequence, and then every sequence will be in one common place, that is virtual sequence, and virtual sequencer, as I told, that is what here is.
But how number of agents are more than two? That I didn't get. Like
Yeah,
you showed me.
actually how means we have three agents now, three destinations now. So for three destinations we may have three different sequences, because three destinations will expect three different datas at a time, not at a time. Actually, we have three different destinations. So three different destinations will expect three different datas. So our test bench should be able to deliver different data for different destinations. Yeah, we can use one common agent, but it is difficult. Sometimes some errors may occur. So for that purpose, we are creating different agent. Okay, for destination one, we will have different a particular agent, which can, if we need to make some alteration, if we need to make some modification, customization in the sense, instead of going to that particularly one agent and instead of searching everything, if we directly go to, if we have some information, you need to do some customization, particularly for the destination one. Like that, if we know means, we can directly go into that particular agent and we can make some alterations. That's why we are having different agent. And we will see when we go into the code, we will see about that.
Okay. Thank
Okay,
you.
finally, yeah, sure. Then here we have test. Okay, and we all know test is the top layer, and where it is, see, here it is, UVM test. It will obviously, it is going to have our environment. We will create our environment here only. Okay, where it is, see here, no, it is agent. Where is our environment? Actually, we create our environment in this yeah, here, see, we are creating it. Yeah, we are creating the remaining agents also. I will tell why we are creating here, I will tell that. But as of now, environment will be created in this test, and inside the test only, we will have our sequence. I think you all remember that architecture. In that architecture, they show like in the test block only we have our sequence, so it will generate. Where here, while go through this code, I will tell you where it is, like that. And finally, the test bench. Okay. So test bench is actually, it is not that much complex, because we have separate blocks, and we are going to we are going to pass that signals. That is a connection between the DUT and test bench. We are going to implement that connection. That is why we are using this test bench, and we will generate a clock. It seems, yeah, we are generating a clock here, and we will initialize some initialization will happen here. That's all. Test bench is actually easy because there are a lot of complexities inside. No, so we will do all the operation in the inside blocks itself. Okay. So when it comes to test bench, we will mainly concentrate on the connection between our DUT and our test bench. This is what here. Okay. Now we will go deep into the each block. Okay. So the first one is where it is write transaction. Okay. So as I told, write transaction will hold what are all the data we are going to transmit and what is the information that and which are all the inputs we are going to randomize, and what about the constraint, what how should be that data, that constraint and all comes under this write transaction. Okay, see, you can notice here, like there should be three address. Okay, that is what they are here. Our header is not equal to 3 in the sense header should be, we have three destination only, no? So our header should be 0 0 0 1 and 1 0. So if it is 3, that means if it is 1 1, it should not have this fourth destination. That's why they are making this constraint. Okay, so by making this constraint, our header will not create this 1 1. That is 3 in decimal. That is what they have given here. Okay, then constraint. Then for payload, we have constraint like it should be from 2:7. So our size should be from 2:7. That means we should have our payload size within that 6 bits. That is what they are telling here. And it should not be equal to 0, because if our payload is 0, obviously there is no data it means. Okay. Okay. Then. And here you can notice they are using extern. So you no need to confuse with this extern. Extern in the sense, if we are using our functions outside the class, we just use this extern. That's all. Other than that, there is nothing. Okay. So if we are using, why we are using outside our class means for some clarity. That's all. Inside going inside the class, and instead of searching, we can come out of the class and we can make a search here. Okay. So for that purpose, here extern is used. That's all. So we no need to confuse about that. And see, as I told, no, there are some procedures which we need to be followed. That is what this function write transfer construction. See, when a function comes with a new, it is a constructor. Okay. So why we are calling super.new in the sense we are calling the parent class because it is extended from UVM sequence item. So our parent for this write transfer, write transaction, parent is UVM sequence item. So inside that UVM sequence item, we may have some functions, inbuilt functions. We have some variables, some members. Okay, we may have some tasks which are pre-built. Okay, so we no need to worry about. We no need to build from scratch. Okay, so when we inherit from UVM sequence item, it will take care. Okay, wait a second. Okay, so when we inherit from the UVM sequence item, it will take care about that. Okay, so no problem. That is why we are using this super.new name. Okay, so the next one is just a print. Okay, so UVM printer, that means it is a factory. Okay, we first see here we are registering this write transaction with the factory. Factory means UVM object utils. So we are registering with the UVM factory so that we can use what are all the accessories available inside that factory, in the sense reset, override and UVM printer and like configuration concept we can access. Those are all the accessories inside that factory. So we can access that by registering our write transaction with the factory. Okay. When we go inside, see, they are just using this UVM printer and they are extending, they are calling the parent class do printer, and they are calling, taking the functions, methods from the parent class, and by the help of the parent class, they are printing it. Okay. It is similar to C. In C, we use printf, no? So same here. Instead of that, in our UVM, we have this printer.print field. Okay. So where this printer.print field function actually works is in our parent class. Okay. It is what it actually works, how it works. Those informations are given in the parent class. We no need to worry about that. But we are just calling that parent class and we are using here, okay, in the child class. That's all. So printer means obviously it is going to print the header, and it is going to print the payload, and I think here the data payload will be print. Okay, see here it will print the payload here, and here it will print the parity. Okay, so it is simple. It is going to just print. Okay, this is what this write transaction is of. Okay, and here you should notice one thing, okay? As it is a write transaction, okay? I think I explained you in the previous section, no? In the paint, I explained, how the parity is generated like that. So since it is a write transaction, we need to generate the parity, okay? That's why they are doing here, okay? So that's all from write transaction. That's all. See, and one more thing is this is post randomized. That is, once the randomization is done, once our header and payload is done, we need to do this parity. We need to upload this parity finally. Okay. In our frame format itself, we come we saw no like there's a frame format like header, data payload, and then we have parity. Okay. That's why we this parity come with the post randomization. That is after randomizing, after doing that randomization and transaction, after the transaction is ready, then we will upload this parity. Okay, that is why it comes under post randomization. Same for retransaction as well. See here in transaction. See, I think you all familiar with this count. Why this count is 29? Obviously, we are going to receive some transaction, but still, if our count is 29, that is till 29 clock cycle, 29 in the sense 0 to 29, that is till 30 clock cycles. If the receiver didn't respond, means our router will automatically do what it is soft reset. Okay, so our P4 will be soft reset automatically. Okay, that means it will move to the high impedance state. I think we come across this statement with in the previous session. I think. Okay, okay then. Same here. See, same extent. Actually, in this project, okay, in every place we are using this extend only. Extend in the sense, instead of using our function inside the class, we are using outside the class. Okay, for that we are using extend. That's all. And as I told, that same procedure we are calling the parent class. Okay, here by using parent class constructor by using super.new name. Okay, then as usual, for reading also we are printing and we no need to create parity here because parity is generated in the write class and it will be received in the read transaction only. Okay. So after read transaction, see as I told, this is the logic and there are some procedures as I told. See for constructor we need to call the parent class because inside that parent class we have some methods which will take care of the inbuilt methods. Inside that there may be some inbuilt methods which will do some operation internally. So for that we are calling that parent class constructor. Okay. These are the procedures. We should remember this, and inside there will be some logic I will teach you. But other than that, there are a lot of codes inside that you should go through that. Okay. So in that case, if there is any doubt, please you can ask me. We can. Okay then. Then here our sequence item is done as of now. Then we are moving to the sequence. Okay. So as I told, sequence item will have what are all the inputs we are going to pass and what are all the outputs and which are the inputs we are going to randomize. So for a transaction, what are all the basic inputs and what are all the data we need? It will be come under this UVM sequence item. Okay. So someone should generate the transaction. No? That is UVM sequence. Okay. Where it is? See, write sequence. So it is actually we are passing our transaction here as a parameter because this class, this sequence is a parameterized class. Parameterized class in the sense this is a write transaction. Okay. So we are conveying our parent, that is UVM sequence. Okay. Here the child is router write base sequence. Okay. And our parent is UVM sequence. We are conveying our UVM sequence that our transaction is write transaction. It have this data. It have this data type. So we are going to make a transaction for this type only. Like that we are for that information for to convey that information we are using a parameterized class. Okay. So it is also an object. Okay. So why component, why object in the sense? See, component means it will be there throughout the compilation. Okay. It is like a fixed component in nature. For example, monitor will be there throughout the compilation and the sequencer driver will be there throughout the compilation. But when it comes to sequence, usually what it will happen, we know, no, it will generate a transaction, and that transaction, once that transaction reach its end, the transaction will be destroyed. Then we need to generate one more transaction. Like that, create and destroy will happen, no? So in that case, we will initialize as a object, which is a non-permanent one. It will not be there throughout the compilation. It is not a fixed component. It will change. Okay, that is why sequence is a object. Okay, so UVM object utils, and then same here also we are using a constructor outside. So here you can notice they are calling the parent class here. Okay, so here what all the logic we need to see is in the here, see, here it starts. Okay, so the same after completing this, wait, I will tell you in setting. Here we are using constructor. Okay, so we all know why constructor is up. Then what we are using is, see, class router 3. That means here we are creating, I think here we are creating, yeah, see here the payload. Okay, so here for 3 destinations we are creating a payload of 5. So payload 5 in the sense, see this, I know here in this 41 line. Actually, wait, I will increase the font. Okay. 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 See here, header means we all know. Okay. So it will initialize the header, and see here, header 7 is to 2 is equal to 5 in the sense our payload size is 5. Okay. So
Sir,
obviously,
can you please
yeah.
increase a bit font size? So very
Oh,
small.
still, okay. Now it is good.
Yeah.
Okay. Actually, that's why I increased. I forgot about that, so that I increased. Okay. Okay. Now it is visible. No. Okay then. Okay. Header in the sense
Sir,
we
little
are going
more.
still. Wait 1 second. Actually, now it's okay. Oh?
Yes, yeah.
Okay then. Okay. See here in this header, there will be obviously first 2 bits for address. Address in the sense the destination 0001 and 10. Okay. And see what they are mentioning here in this first 41 line, and in the header 7 is to 2 is equal to 5 in the sense our payload size is 5. So what it means is we are going to have 5 payloads. 5 payloads means each payload is of 8 bit. So like that we will have 5 payloads. Okay, that is what they are mentioning here. And then this is some separate case. Okay, if we need we can use, because why I am telling like if we need we can use, why I am telling like that means here you can see we have 14 payloads, but they are not mentioning any address. Okay, it may go to any of the destination. It wherever we require, it may go to any of the destination. But I will see in the next slides. Sorry, in the next blocks, you will see our payload size is 5 actually, but here our payload size is 14. So what happen is first 5 payload will be uploaded into the heap 4. Okay. So after doing that 5 payloads, we will take the next 5 like that. So one read, one write. So one P4, that is one payload is done, one payload will be uploaded. Then that next payload is done, then next payload is uploaded. Like that, this 14 payload will be processed. Okay. So for that, here actually they didn't mention any destination. What it means, it may go to any of the destination as required. Okay, that's what they are given here. Yeah, this is what retransaction. That is a sequence. Okay, here you may ask like, see, this is the core of the sequence. Okay, like from here to here. So what here happening is in the 72 in the 72 line, you can notice like we are creating the transaction. Here only we are creating the transaction, and start item in the sense, wait here. Once again. See, start item in the sense it is a sequence. Okay, let's go to the driver, and in the driver here, if you notice, see here, or this in driver, see sequence item port dot get next item. Okay, so these two have some connection. What it means? Where that we will go to that sequence once again here. Okay, what it means is, see, start item in the sense we are going to start our transaction, but what actually happen is our sequence will request to the sequencer. Here there is a transaction I need to transfer, so I need your permission. Like that, our sequence will request the sequencer, and our sequencer, once the driver is ready, okay, that is why that get next item, no. So our driver will tell to the sequencer like I am ready to get the transaction. Like that, if the driver tell to that sequencer, then sequencer will give the signal to the sequence, then sequence will start the transaction. Okay, so where that particular line, yeah, then it will start the item, then it will asset in the sense it is randomization. Okay, it is checking whether the randomization is performing or not. Okay, for that checking purpose, here assert is happening. And once after completing the first item, okay, see this start item and this finish item is for one single transaction. Okay, we may have multiple transactions, so for single transaction our start item and our finish item should act. Okay, once the finish item signal is sent, what it means, yeah, completely transaction is done. Like that it will indicate. Okay, so when you go to this driver means, here it will ask, see, sequence item port get next item. Okay, so after completing that transaction, it will send a signal to the sequencer like, yeah, item done, I received the item. Like that it will give. Okay, so this communication, this is called as handshaking mechanism. Okay, so you can ask like, in the sequencer we are not having anything, we are not implementing these things and all, why? Like that you may have a question. Why? In the sense, inside the sequencer, as we all know, it is an extended class, UVM sequencer. It is extended from UVM sequencer. So inside that UVM sequencer, we have all these procedures. Okay, so since it will make some, how can we tell? Since it will make some difficulty for us every time, if we implement the same process for that handshaking mechanism, it will be difficult. So instead, if we have some parent class and we are extracting that functions from the parent class means, it will be easy for us. Okay, that is why we are using the this sequencer. Okay, in the sequencer we are not using anything complex, we are just extracting from the parent class. Okay, so where we left, we are here in the sequence. I will try to complete it today. Okay, can be, you can revise from tomorrow onwards. Okay, then here we have we come across with write sequence, then here we have read sequence. So obviously write sequence will generate the transaction and our read sequencer will read the transaction, and the same procedure. See here, that same constructor, and inside the task we will repeat this action for 3 times. Why 3 times? Because we are having 3 destinations. Okay, while reading, this is particularly for reading, because destination only read, no, our source will write, it will generate, our destination only read. Okay, so for that purpose, here since we have 3 destinations, we are repeating the same action 3 times, and as I told you, our payload length is 5. That is why they are counting 5. Okay, whether we are receiving all the 5 payloads or not. So for the counting purpose, we are using this. Okay, this count is equal to 5. Like that we are using. And as usual, the start item, and after starting a transaction, and after completion of the first transaction, it will use this finish item, the same. And here, this UVM info, in the sense, it will print the information. Actually, see, UVM info in the sense router RD sequencer, that is router's read sequencer, and printing from read sequence at the time. Like that, it will print some information about this current block. What are the transaction, what is happening in this current block, it will be printed using this UVM info. Okay, so we can use these type of infos like UVM keywords. When we can use these type of keywords means whenever we are registering our component or object with the factory. Okay, this fifth step. If we register, then only we can use this. Okay, that is why that registration is important. I told you, no, inside that factory there are some accessories. We can, if we register our object or component inside that factory, we can access this accessories. Okay, inside the factory. That is what happening here. Okay. Okay, then we will move to the. Okay, sequence is done. Sequence item is done. Obviously, our next thing will be sequencer. See here, sequencer. Okay. So class router sequencer, write sequencer. So see, as I told you, see how simple it is. So this time you may have some doubt. So you are telling like sequencer is a mediator between sequence and the driver. There is a handshaking mechanism happening, but nothing is mentioned here. Why? In the sense, it is a extended class. Okay. So all the informations are present inside that UVM sequencer itself. Okay. We are just extending it from this constructor. See, super dot new. That name, comma parent, in the sense, parent in the sense, it is mentioning that constructor. Okay, in that extracted parent, it is mentioning that parent. Here the parent in the sense UVM sequencer. And you can notice one thing. Wait, see, in the sequence and sequence item, where those, see here, in the sequence and sequence item, while writing the constructor, there is only name, no parent. Why? In the sense, see, for objects, there is no hierarchy. Why there is no hierarchy? It will just create a transaction, and after it is done, it will destroy and it will create the new one. Okay. But when it comes to object, when it comes to component, okay, where it is. Yeah. So when it comes to components, okay, here it has some hierarchy. Hierarchy means they will have some parents. So it is a child, like that there is a hierarchy, no? So for mentioning that, we are using parent here. We are using one more UVM component parent, and we are calling the parent class functions here. Okay. So see how this is easy actually. Sequencer. It will be done internally in the parent side. Okay. That's why we are calling super dot new name comma parent, like that. And then we will have our here it is write sequencer. We will have our read sequencer as well. The same operation here here also. Okay. Just we will write a constructor and we call our parent constructor. So inside our parent constructor, there will be the information which are all required to make this handshaking between the sequence and driver. Okay. So from it is easy. Sequencer is easy. Okay. But yeah, remaining there are some blocks. No, it will be difficult. Difficult in the sense it is not difficult. It is somehow some logics are there. Okay. That is what. Okay. Now sequencer is done. Then what about next one is driver. Okay. Where is here it is read driver. Okay. Where it is write driver. Yeah, it is here. Okay. What is the use of driver? It will drive the actual signal to our it will drive the actual data to, that is the transaction data to the DUT. Okay, this is what our driver will do. So as the same, we are extending it from our parent class, and see this is factory registration. Here we are using component because driver is a component, and here you can notice one thing like virtual interface. So now you may have a doubt. Okay, we come across with transaction, driver, sequencer. Where is the interface? Like that, you may have a doubt. See, I think we have discussed it with in the previous session itself. Driver is written here. Okay, and don't ask why it is written here. They are written here. That's all. We can, if you need to return in the left side, you can. Okay, as we are working at that time, it is written like this. Okay. Okay, then see, this is our interface. So we all know what is the interface. It is to make connection between the test bench and the DUT. Okay, so in between them, we need an interface. That is what this particular interface block is of. It will have all the connections which are going to involve in our transaction. Okay, so inside there is a clocking block for synchronization. All these signals should work in the same clock now. For that, we have this clocking this clocking block, and this is default. Actually, it is called as skew. Okay, so why we are using it is our input should be sampled after one clock cycle. Okay, at the same time, our output should be sampled after one clock cycle. They are setting like this. Okay, it is default inside the clocking block. Okay, actually, it is called as skew, I think. Yeah, I come across with this word especially, and yeah, it is skew, it seems. Yeah. Okay, then, but just as of now, you can note it like there's a default timing. Okay, why we are mentioning it is our, one second, I will search it. I had that in my note. 1 minute, please. Actually, the name of this is Q18. Or actually not in this note, I think. Okay, no problem. Okay, actually it is skew only. Okay, skew in the sense that is what I am telling you. That input will be sampled after one clock cycle, and output will be sampled after one clock cycle. Okay, yeah, that is skew only. Okay, so it is called as skew. Okay, for this particularly this 22 line, no, it is skew. Okay, okay then. So here you can notice in the 6th line, virtual router, if that is virtual router interface dot write, that is WDR means write driver mode port. Okay, this is virtual interface. This is what I think. Once again, we will search in the right side. See, the right side there is a mode port. See here, this 53rd line. Okay, so why it is mode port? You all know, no? It is for direction. In which direction our input should travel, like that. For directioning, we are using mode port. And while calling our interface inside, how we will call means inside the router. See, our interface name is router. Okay, so inside that router, there is a right driver mode port is there. Where that right drive mode port? Here it is there. So we need to create a virtual interface for that. That is what they are telling in this line. And why in virtual interface? In the sense, our class is dynamic in nature and our interface is static in nature. So dynamic can't be contacted, or dynamic cannot be interfaced with the static. So, but we need to transfer our data. Somehow we need to make a transaction. We need to make a communication connection. So for that purpose, we are using virtual interface. So virtual interface is dynamic in nature. And obviously, at last, we are going to connect everything with the physical interface in the test block. Okay, in the test bench, we will see, no problem. So this is what router driver is. Okay, so see the same procedure here. They will call the parent class and see. But you should notice the main, why we are using this router. What is this driver is of? See, super.build phase. So you may ask, like, there's a build phase, and here what we are building is, I told you, no, configuration. See, which configuration they are calling here? They are calling agent, write agent configuration. Now you may ask me a question, why we need to call this write agent configuration inside this driver? Like that, you may have a question. Why in the sense? Wait a second. See, where is our configuration? Write configuration. See here, write agent configuration. Why in the sense? Obviously, our driver comes inside that agent, but our driver should know whether the agent which we are, that is the driver, okay? The driver is present inside the agent, no? So the driver should know whether this agent is a active or passive. And see here, there is a count. Why this count? Obviously, our driver will transfer some that transaction. Our driver will send the transactions to the DUT. So we should have a count, like how many data is transferred. What happened here? Actually, for everyone, call is holder now. This meet is holder for everyone here. Hello. Here, right now, is there any hold happen here in this meet? Hello, anyone can answer no? Is there any disturbance happened in this meet right now? Like some hold like that?
No.
Oh, okay, for me only. Okay, no problem. Actually, recording is happening now. Hello, recording is
Yes.
happening now.
Yes, sir.
Yes,
Okay.
Happening.
Okay, thank you. Actually, my meet became hold now. That's why I'm asking. Okay then. Okay, we will see. See here. Here there is a count. Why we need this count means we need to know, okay, whether we received the expected count or not. That is, we received all the transaction or not. That is what. And see here they are configuring that. Okay. So and they are calling this parent also. So that's why our driver is here. Where to is right driver? Yeah, here. That's why our driver is configuring this agent here, because while configuring then only we know, okay, what type of agent it is and where the driver is, in. It is in a passive agent or active agent, and to get that count. Okay, so while configuring we can access that, no? While configuring that particular block, we can access whatever inside that block. Okay, so that is M configuration. Okay, so that name they have given here as M configuration. Where that M configuration come from is, see, is just instantiated here. Okay. Okay then. So we have configured, and then see here we are connecting that virtual interface with that configured interface. Okay, because it is agent now. That's all. Then for driver, this is important. See here, this we discussed now, sequence item port and get next item. Okay, so what it means is, as I told you, our driver will send the request to the sequencer, like, yeah, I am ready to get the next item, and you can send the next transaction, like that. It will tell to the sequencer, and our sequencer will tell it to the sequence, and it will send to DUTs. I will tell you. See, it will get that transaction and it will send it to the DUT. Then after that transaction, particular single transaction is done, it will send the item done. Okay. So then next transaction will happen. The same procedure will repeat. Okay. And driver need to do one more operation, that is, it should send that transaction, it should receive that transaction from the sequencer, and it should send the transaction to the DUT. Okay, so for that purpose, see here, this task is used here. Why this task is used means the transaction should be sent to DUT. Okay, so see here, connections will be there, no? And you can notice in this line, in this 81 to 83, what they are telling is, we are sending to the DUT. Okay, so you'll note this 83rd line. Okay, VIF, VIF means virtual interface, and write driver clocking block. Inside that clocking block, there is a data in, that is from that side, DUT side. So for that DUT, for that particular signal, we are sending our header, that is XTN means transaction that is happening in our test bench. We are sending our test bench transaction. First we will send header no, then payload, then after that parity. So first we will send the header no. So here what it means, our header transaction is sending to the actual interface from that side, DUT side. That's why here happening. It will be reverse in the monitor. We will see that also. Okay. So see here, we are transferring the payload here. Okay. This wait and all, yeah, as I told, no, there is some why we are waiting, because our clocking block should not be busy. It should able to receive the data. So when it is ready to receive the data without busy, then we will transfer our data from our transaction to that is our test bench to the DUT. Okay. These are some signals. If you go through the code means it will be easy for you. Then see, finally we are transferring our parity. Okay. That's all. Other than that, here see report phase. And you can note here, actually in UVM we have phases, no, like build phase, and we have connect phase, front phase, like that. We have 9 phases, and in that report phase also one. Why we are using the report phase means it will report in which block it is happening, in which component it is happening, and what is happening, and what all the number of transactions here, when it came, from where it came. It will report. Okay, that's all. In this, what is it? The write driver. Then we will move on to the read driver. Okay, same in the read driver with some small changes in that logic alone. Here, there is our read driver. So inside the read driver, same. See, this first procedure and all same only. Okay, till this constructor, everything will be same. Okay, we will just do the factory registration, and we will instantiate this configuration. Sorry, virtual interface. And since we have, we need to check whether our agent is active or passive. Why we need to check means, in order to drive some data to the DUT, our agent should be active in nature. Okay, so if we are doing only monitoring process, at that case our agent should be passive in nature. Okay, so to check that purpose and to get that in that configure agent, we have count, no, static count. For receiving we have some initialized some count, and for transferring we have initialized some count. So to get that, for accessing that configuration, we need to initialize here. Okay, and then see the same only. Actually, read driver is somehow simple than a write driver, because in write driver we need to uh, wait the same only. See here, the sequence item port, get next item, then we send it to the DUT, then we will finish, like we will end the transaction by item done. Okay, so same here also. Okay, here actually see, receiving sending is okay, but when it comes to driver, obviously everything is going to happen from test bench to our DUT. So we are sending our data from our uh, test bench to our DUT. Okay, so this is the DUT signal. Okay, through virtual interface we are sending our data to the exact DUT itself, design itself. Okay, DUT means design under test. I think you all know. That is simple only. Okay, so here they are mentioning like repeat 100. Okay, if we need, we can customize. See, to be frank, I don't know, repeat 100. There may be 100 repetitions will happen. That is, this virtual interface clocking block. That is, this clocking block may generate 100, but as of now, we are generating only 5 payloads. Okay, and we have only 3 destinations. Here, this repeat 100 in the sense, see what they have mentioned here. Virtual interface RD driver. Okay, see, we are moving to this driver block, and inside the driver block we have read enable. Yeah, they may mention like it should repeat, this process should repeat for 100 times. For that they have mentioned here, but this logic I'm little bit weak in this. Okay, this particularly 77 to 80. Okay, 1 second, we will check. repeat 100, and inside that RDCB, driver CB, in the clocking block we have. Oh, okay. See here, actually I told you, no, here we may receive, we don't know how many transaction we are going to receive, but yeah, 100 is actually a huge number, we can reduce it, but here they have given 100. Okay, so while receiving, we will receive through this interface only. Okay, so it will actually mention this clocking block enable, but this 100 repeat. Okay, I will check and tell you, no problem. Okay, then see here, in this read driver also there is a report phase. Okay, so as I told you, the same will be happen. It will report what from where it is from and what are the information like that. Okay, okay then. And next, after driver, we will move to the monitor. Okay, where it is, first one is read monitor. Where is our read monitor? Yeah, here. See, what is it? Okay, see here. So same. The first procedures are same, but here, yeah, here also we are going to take this. But what you should notice while coming to monitor is this analysis port. Okay, so before we used port, export, and when it comes to if both our producer and consumer, like what I'm telling is, if our both component are initiators, okay, in that case we use TL and FIFO, but here our monitor is going to communicate with one to many. One to many in the sense why they are giving here is it is going to communicate with scoreboard, and additionally if we have some coverage, or in future if we develop some coverage, in the sense we may have one to many connection. In that case we should use this analysis port. Okay, if you go and search also, okay, what is the use of analysis port, they will mention like it is for one to many, that is there is one component and it is going to communicate with many other components. For that case, we will use UVM analysis port. This is one advantage in UVM as well. When we are using system Verilog, no, we need to create mailbox for every component connection. For every components, we need to create a mailbox. For example, I created in that time for monitor to scoreboard, I create a mailbox and we need to initialize that. And for monitor to coverage, we need to create a mailbox and we need to initialize that. We need to follow the procedures. But when it comes to UVM, it is easy. UVM analysis port, then it can communicate with one to many. Okay. Then same procedure. See here, they are using the constructor, and here the build phase. We are getting that configuration. Why? Because monitor also should know, no, whether this agent is active or passive, like that. It should know, no, for that. And also monitor also should know the receiving count. Okay, so once again I'm telling, see here, if you go to this configuration, okay, where to configuration, see, if you go to this write agent or read agent configuration, anyway, you can go to, see, if you go to this configuration, see there are some count. Okay, and there is a whether our agent is active or passive. That information is here. Okay, so to access all this information, we can get that configure. We can see here we are setting this configure. Setting means here we created. Okay, and when it comes to that is monitor, right monitor. See, when it comes to this block, we are just getting here. See, note this 36th line and note this particular sentence. We are just getting that configuration because we have a block there. We need to get that. We need to access that. What are the members inside that? We need just the access. Okay, so we are getting that from the configuration router, right, for agent configuration from there. Okay, and then as usual we are initializing our virtual interface with the configuration interface, and the see here collect data. What is collect data? Monitor will collect data from DUT. Okay. So this is a task. Okay. See below, collect data task. Okay. We have some information. Okay. Collect data means what we are going to collect. We are going to collect the output data from the DUT. See, as I told you, no, it will be reversed. See, you can notice here. Actually, data receiver dot header. Okay. This is a transaction side. That is our test bench side. And where we are going to receive that data mix from the signal DUT side. From inside the virtual, there is a clocking block. Inside the virtual interface, it will go to the actual interface. And then in the actual interface, there is a write monitor clocking block. And inside that clocking block, there is a data in. So that data in from the DUT will be transferred to this our test bench transaction. Okay. So monitor will take that and it will use it for analysis purpose. Obviously, the first data will be header. See, here we are receiving payload in the 78th line. And these are the condition. It should not be busy and it should be a valid one. Like that, there is a condition. Okay. And for again, as I told you, the last byte will be the parity byte. Okay. So first one is header, then payload, then parity. So here we are getting the parity at last. So as we told in the theoretical part, to check the parity, our data no need to be valid one. So same here. Okay. The same logic. I think you can understand it. Okay. Then here what happening is, see, making the count plus plus. Why in the sense we are receiving the count now. So we are counting for the we are making the count. See, MCF means M configuration. Configuration means that agent configuration. Inside that we have no monitor received transaction count. Where is it? We will check. See here, where configuration. See here, in this configuration, note that 12th and 13th line, we have initialized here, and by accessing this configuration, okay, by getting this configuration, we can access that in our actual monitor block. Okay, that is what happening here. See, since we configured in this, where we configured, one second. Yeah, since we configured in this 36th and 37th line, you notice we have configured, we have get that configuration. So now we can use that wisely. Okay. That is what this count is of. Okay. Then mode port dot write in the sense where we are receiving monitor port dot write in the sense we are going to write it in the monitor. Okay. The received data will be written in the monitor, and you may ask why it is written, why this write is used like that. You can ask me. So why means in that normal port, no, like sequencer to driver, we have sequence port and we have export. Okay. Likewise, when it comes to analysis, we use this write. Okay. Instead of port and export, we use this write. Okay. So as I told you, see, this monitor using analysis port only, no. So that's why we are using write here. Okay. So it will write the received data. That is what it is. Okay. Simple logic only. And at last, we are going to use the report base for reporting our details of the transaction. Okay. This is what write monitor is of. Then we will move on to the read monitor. Where is read monitor? Yeah, this here. Okay. See, the same will happen. The same analysis port. And we are going to take the instance of the configuration, and we are going to get make a virtual interface for the actual physical interface. One second, please. I will drink some water. Okay, then. See, as usual, we are having some constructor, and we are extracting from the parent constructor here. And as I told that, since it is a component, we have name and parent. Why parent? Because we have some hierarchy when it comes to component. We have a parent component, no? So to mention that, we are using parent here. When it comes to object, there is no hierarchy. It will create and destroy. So we just use name alone. Okay. Okay, then see here, function void router RD monitor in the sense it is build phase. So you can ask me a question like why these configurations are coming under a build phase. Why means inside the build phase only we will completely build the component. Okay, so after building the component only we can configure or we can make some alterations, we can override, all that are made only when we are build our component. Without building, where we can configure, we can't configure, no. So for that purpose we are using this configuration inside the build phase. Okay, then so same here, connecting that virtual interface to the configured interface, configured virtual interface, because it is agent, no. We are accessing from the virtual interface. Actually, we are accessing from the router configuration, agent configuration. So we are mentioning, we are connecting it in the connect phase. Okay, with that agent configuration. Okay, then as usual, collect data. In that collect data, we will have where we are collecting and what we are collecting. See here, as I told you, here in the driver, we will send the data to the DUT. In monitor, we will receive the data from the DUT. That's why here interface is there and we are receiving it from interface, and where we are receiving it from our actual test bench transaction. Okay, first we will receive header, then we will receive payload, and finally we will receive the parity. Okay, actually where the parity is here, payload, see here in the 73rd line we are receiving the parity. Okay, so as I told, since it is analysis port, we use monitor port dot write. Okay, and you can refer, like you can go and refer that analysis port, means there won't be any port export and implementation. Simply there will be analysis port and we will use write, and after writing we will use print. Okay, and analysis port is for one to many, one component to many component communication. And why in monitor they have this analysis port, in the sense it is going to communicate with scoreboard, and in future if we include some coverage, means it will communicate with the coverage also. Okay, then, and as usual report phase. Okay, then after monitor, where we are going to go, we are not going to environment. Okay, why? Because this sequence of driver monitor will comes under a agent. Okay, so as I discussed, see, first we configure this agent, whether it is active or passive, like that we will configure. See, this is our write agent configuration. Wait, I will show you that read agent configuration. Where it is here. Okay, there are two configuration, and one is write agent, one is read agent. So what we can do here is, yeah, we have the configuration. If we need to make it as a passive, we can, or if it need to act as a active, we can make that. That is what this configuration is of. Okay, then which is active, which is passive, in the sense, obviously our write, that is our source side, because it is going to write and it is going to drive and it is going to monitor. So for that we will use write, that is active agent, that is all the three component like driver, sequencer and monitor should work. Okay, that is active agent, and only monitor is working. That is, it will just take data from DUT and it will just analysis. That's all. Other than that, that agent will not do anything. In that case, our agent is passive. Okay. Okay, for the configuration purpose, we use write configuration and read configuration. Then, as I told you, see, inside the agent, we will create the components. Which are all the components inside the agent? Monitor, sequencer, driver. Okay. So monitor, sequencer, driver will be created inside the agent. See, as usual, we will configure our agent because it is main. Okay. See here, Okay. Yeah, it is your. Okay then. See here inside the write agent, first we are creating the monitor. Then see, as I told you, if it is active, then we can create this. Okay. If it is passive, we no need to create this driver and sequencer, because driver and sequencer will do nothing in the passive agent. Okay. And I think you all know it as well. In the active, yeah, driver will do that driving operation. It will drive our actual data through the DUT, and our sequencer will make the handshaking process between the sequence and driver, and it will control the transaction flow. And yeah, like that, the sequencer and driver have some purpose, no? So that's why we are using this if condition. And if our agent is active, then we can implement this driver and the sequencer. If it is passive, we no need to create. Okay. Then see in the connect phase, we are connecting. In the agent, what we will connect is, we will connect our driver and the sequencer. See here, write driver dot sequence item port dot connect write sequencer dot sequence item export. So why sequence item port in driver means driver is requesting, it is the initiator, and our sequencer is the it is like a target. Okay. So if the driver initiate, our sequencer will process and give the data. Okay. So which is the initiator is port, and which is the target will become the export. Okay. In the TLM port concept. Okay. In the TLM analysis port, it will be different. Yeah, it is same only, but little bit there will be some small differences. And when it comes to TLM FIFO also same only. See, all TLM analysis, FIFO and port export fully same only. We can notice some small difference. Okay. Okay then. Now we will move to the read agent. Okay. Where our read agent? See our read agent answer. Okay, only three is here. Okay, no problem. Okay, actually, as of now, you are clear, no? That concept. The code completely, yeah, you need to go through. But as of now, that concept, that logic, why we are using that things and all. As of now, you are clear, no? We come to. Hello, it is clear only, no? You can understand that logic and concept, no? Yeah, code will be, you need to go through once, but other than that, that concept and logic. It is okay, no? Hello, anyone?
Yes, okay.
Okay then. Okay, now we will move to the read agent. As I told in the write agent, read agent have some configuration. Sorry, here I forgot to mention this write agent top. Okay, why this write agent top? As I told you, see here, they are mentioning like they are instantiating the agent, and they are mentioning a dynamic array. They are instantiating a agent, and they are giving a dynamic array variable. Why in the sense, if we have more than one agent in the write sequence, in the write agent side, if we have more than one agent, we need to make some space. At that time, if we don't know how many agents are there, then if we make our size high means it will be waste, or if we make our size low means it will be not enough. Okay. So it should be make at the runtime. Okay, that size should be allocated at the runtime. So how many agents are there? That size should be allocated at the runtime. So for that case, see here, we are allocating it dynamically. Okay. Then we are instantiating environment configuration. Yeah, we need to use it here. And see here, in the build phase, we are getting that configuration. And see here, we are creating that. So we don't know how many agents will be there. There may be only one, or there may be 2, 3 like that. So for that, we are allocating the space here in the build phase. Okay. And see here, they have mentioned for each. Why they mention for each? Because whenever in array, we need to know about the size, but exactly right now we don't know the size, but there will be some, there is an array is there. We use this for each, okay? So it will, what is for each in the sense, it can mention each and every element inside the array, okay? So without mentioning, if we don't know what is the size of the array, or if we need to know what is the size of the array, we can use for each as well, okay? It will allocate automatically. That I value will be increased automatically by that for each, okay? Based on our requirement, okay? So see here, we are creating for every agent. If we have 2 agent, we will create 2 agent like that. We use this create. Then this topology in the sense, it will print everything from starting to end. Everything it will print, okay? The hierarchy, the complete hierarchy, where it is coming from, and from which agent, from agent 1 or 2, like that. The complete hierarchy will be printed. That is why we are using UVM top dot print topology, okay? Topology in the sense, from top to bottom, that hierarchy will be printed, okay? Same in the read as well. See, read configuration and read agent, same. Here we are going to build our, if it is a passive, it won't build this sequencer and driver. If it is active, it will print, okay? Other than that, everything is same only, okay? See, here we are connecting, okay? In the agent, as I told you, we connect driver and sequencer, okay? And monitor and scoreboard will be connected in environment block, I think. We will see, no problem. And as I told, there is a agent top, read agent top, and where we can, if we have more than 2-3 agents, we need to allocate some space dynamically. For that, we have this agent, okay? And then see here, function router. So same here, okay? We are using that constructor, okay? And we are calling the function constructor. We are calling the parent constructor here, because inside that there will be some inbuilt methods will be there, inbuilt variables, inbuilt operations will be there, okay? So while calling that, we can access that, okay? What are all inside that parent, we can access, okay? So same here, we are configuring our environment, okay? And then see here, we are creating separate space for every agent here, and we are creating every how many number, we don't know how many number of agents here, so we are using for each, and we are mentioning inside the square bracket, we are mentioning I. So if we have one agent, it will be 1 or 2, it will automatically allocate because of for each. Then we will create that agent, okay? Then as usual, print topology, it will print the whole hierarchy itself, okay? Then after agent, we need to move to scoreboard, okay? Where is our scoreboard? See, UVM scoreboard. And as I told you, here we are using analysis port. Why analysis? Analysis before you don't need to confuse, okay? We are using analysis port, okay? Why we are using analysis port? As I told you, monitor is communicating with scoreboard, monitor is communicating with scoreboard, and if there is a coverage block, it will communicate. So our scoreboard, here you need to note one thing. See, if we have 3 agent, okay? For example, I'm telling, if we have 3 agent, we will have 3 monitors, okay? If we have 3 agents, we will have 3 monitors. So, but here you should notice one thing, we will have only one scoreboard, okay? So that one scoreboard will check all the 3 monitors expected output one by one, okay? For that purpose only, see here, they are here also they are allocating in dynamic, okay? They are allocating an array dynamically. So when we receive a transaction from a particular monitor, and if there is more than 2 or 3 transaction we need to check from the monitor side, it will allocate dynamically, okay? That is why they are using here. And scoreboard, see, as usual, we are making some space for write, FIFO write, and we are making some space for FIFO read. See, there is 3 space because of 3 destination, and yeah, it will print here, okay? For each I means for every time if there is a first destination, it will be print here. If it is in second destination, it will be print here, like that. Okay. And then we have run phase. See, in scoreboard, the work of run phase is we will get the data. Okay, see the number of packet. We will increase. That is how many packets. In our example, we see in the previous block now, we are sending 5 payloads. Okay. For example, I am telling if it is 5, we are getting 5 data and our number of write packet is 5. And see here, number of, and see, you need to notice one thing. They are using 4. That is, it will work, okay, at a time. Okay. See here, that is the number of read data. We will get the number of read data and we will count that how many data we read till now, how many packets we received till now, like that. And at last, we will check. Okay, where we check, see here, UVM check phase. And I think you are familiar with that phase, no? In that there is a check phase, no? So there we are checking. Note this 111. That is 111th line. So if read data dot header is not equal to write data header, there's a header mismatch. Okay. At the same time, see in the line number 129, if the read data payload is not equal to write data payload, it is a mismatch. See here they are printing payload mismatch. Same thing. See here, if our read data dot parity is not equal to write data dot parity, what it will print? It is a parity mismatch. Okay, but if it is matching, then we will print parity match. Okay, that is what they are telling here. And if our payload is matching, see here in the 139th line, payload is payload match, like that we will print. And note here in this 120th line, if our header, both write and read header match means we will write header match, like that we will print. Okay, for our clearance. Okay. And these and all for scoreboard result. Here they have mentioned, total number of verified with success. That informations will be printed. That is what the check phase. Okay, inside that phase we will print here. Okay. Okay. This is scoreboard, and after scoreboard, where we are going to go this environment. Okay. So before going to environment, we need to see that environment configuration. That's all. I think in 15 minutes, obviously in 9:15 we will complete. Okay. And then if you have any doubts, you can ask. Okay. And you can work in the code. And in between, if you have any doubts, you can convey. You can ask. They will convey to me, and I will clear. Okay. Okay. See here. This is our configuration. That is what are all inside the environment. We have one scoreboard, one write agent, one read agent, and inside that there will be many agents. So as of now, one virtual sequencer, and we have our number of write agents. It will be 1. Here number of write agent will be 3. Like that, some information. Before instead of writing inside the environment, we are having some separate block like environment configuration, and we will configure it inside the environment block. Okay. So see here, where it is router TB. This is the environment block. Okay. So inside the environment, what we are going to do, we are going to create the our agent, and we are going to connect the scoreboard and scoreboard and monitor. Okay. See here, router top agent, that is router read top agent and router write agent top. Okay. And then, yeah, virtual sequencer will be here. And I will tell you, virtual sequencer we will see. Okay. And here you can notice one thing. See, while creating, if M configuration and has V agent, that is what they are telling in all these line are, if it is present, you create, else don't create. Okay. Like, see here in the build phase, as usual, I told you, they will configure the environment. That environment configuration will be get here. Okay. By using get configuration. Okay, and in this 26th line, what they are telling, if there is write agent, then create that. In 40th line, if there is read agent, then create it. And if there is a scoreboard, then create that scoreboard. And if there is a virtual sequencer, then create that. Else don't need to create. Okay, for that they are using here. And I think you are familiar with that create. Okay, which is the syntax for creating a component or object, same syntax, but some small change. Okay, see here, connect this. I told you, no, here you can notice where they are connecting, but before that, see here, what they are doing is they are connecting the agent. Inside the agent, see, what is virtual sequencer? Virtual sequencer, inside the virtual sequencer, we will have the group of sequence. Okay, that group of sequence, where it is come from agent. Okay, so inside the agent we have the sequencer. So all the sequencer have the access in the virtual sequence. That is what they are doing here. See, virtual sequencer dot write sequencer is equal to, in the agent top dot w, that is write agent I dot write sequencer. So they are initializing the write agent. Inside that actual agent is there, no, inside that they are some write sequencer will there, no, so they are initializing that to the virtual sequence, so that in future if we need to access, we can access. See here in this 66th line they have mentioned here for read. Okay, and then here for scoreboard we need to connect, no, see, as I told, scoreboard is connecting with the monitor. Okay, see, in the write agent, top write agent, inside that write agent we will have a monitor, so that monitor will be connected to the scoreboard. Okay, see, analysis export, that is scoreboard is export and our monitor is port. Okay, so as I told you, this export and import will not actually implies. In reality, when it comes to analysis, we will write and print. Okay, but for naming we are using here, we can use like this. Okay, it is not a problem. And see here the same, we are making connection with the read monitor and the read scoreboard. Okay, and as usual, analysis export. Sorry, actually analysis have export and port. I think it won't have implementation, it seems. Yeah, but we use write actually. I remember that we use write in the analysis port. Okay, when we receive a data in the analysis, in case of analysis port, when we receive a data, we will write that. Okay, okay. After that, now we will see virtual sequence and sequencers. Okay, as we know, what is virtual sequence? It will have all the sequence. Okay, sorry, virtual sequencer means it will have all the sequencer which are involved in this test bench. Okay, it will hold all that, and see, it is simple only. Okay, we are, see, if there is if we don't know how many number of sequencer is going to act here, but to make some space for all that, we use this write sequencer is equal to new of number of, that is configuration dot number of write agents, like that. Okay, and we will extract our build phase from our parent. So super dot build phase, like that we will use. Actually, virtual sequencer is easy. Virtual sequence is bigger. See here. So what we are going to use in this virtual sequence, in the sense, see, why we are using sequencer, inside the sequence only, sequence going to communicate. Okay, the transaction will happen and it will given to the sequencer. What I'm telling is the sequencer sequence transaction will happen and it will be given to the sequencer. Actually, sequence will generate the transaction and it will be given to the sequencer. Okay, and see, these are the sequence, and here we implemented the sequencer. Okay, and here, one second. Okay, actually there is one important line here. I will tell you. Okay, see here, this 30. Okay. Yeah. That is initializing random arrays for read and write sequencer. Okay. And see here, assert here what we are doing is we are casting. So we are passing this M sequencer. That is, in our agent we have some sequencer, no? In our configured agent we have our sequence, no? So we are passing it to the virtual sequencer. Why? Because virtual sequencer will hold all the sequences. Okay. So later if we need to do some change or if we need to refer that, we can directly go to the virtual sequence. Okay. That is why they are asserting here. And then where see here, why this is means we are passing our actual sequencer to the virtual sequence. Now our virtual sequence will hold all the sequencer. Okay. Our virtual sequencer now have all the sequencer, and how we can access this? See this 46th to 50th line. We are accessing, that is write sequencer is equal to virtual dot write sequencer. Like that, from virtual sequence we can access. Okay. Same for read sequence. Read sequencer. From virtual sequencer we have our read sequencer. If we need to access, read sequencer is equal to virtual sequencer dot read sequencer. Like that we can access. Okay. See, actually, I'm telling the logic and some of the important blocks. You need to go through this code thoroughly, then only you will know, okay, this is for this, like that. There are some basic codes which we need to do for procedural things. Other than that, there are some logic. That is, I'm telling here, okay. And some important points I'm telling here, okay. Okay, see here, they are creating all the sequences here, okay, in the virtual sequence, okay. And that will be actually sequence will be created in our test only. We will see, I will tell you. Okay. As of now, virtual sequence will hold the sequence. No, for that purpose, we are creating here. Okay. And for start our sequence, we are using this. Okay. Sequence dot start, like that we are using. Okay. And yeah, here see, we are creating the read sequences. I think we have created write sequence here. Oh, sorry, read sequence only. Okay. Okay. 1 and 2 and 3. Okay. Why we are using 3 in the sense we have 3 destinations now. See here, router, write sequence, virtual sequence 1. For 1 we are creating, and see for 2 we are creating the same here. Okay. So we are creating 2 here. Okay. Okay. So this is what virtual sequence is of. Okay. So all the sequence will come under a same in a single unit in a same place, that is virtual sequence. Okay. If we have many sequence means it will be difficult for us to handle. So if all the sequence are in same place means it will be easy for us. Okay. That's why we are using virtual sequence and virtual sequencer and all. Okay then. Now we will move to the test. Where our test is here. Okay. Inside the test only, we will create our environment actually. Okay. See, same, we are mentioning number of read agents and number of write agents. And here it is, yeah, here what it's telling is there a read agent? Yeah, there is a read agent, one read agent and one write agent. And inside that write agent, there are number of one write agent. And inside that read agent, there will be 3 number of read agents. Okay. They are mentioning top level. Top level, there is one agent. And inside that, there will be some agents. Okay. That is what they are mentioning here. We no need to confuse it. Okay. Then function, same here, the configuration. See, here we are making some space. Like if we have write agent, then create it. Okay. How many number of write agent are there? Make some space for that. That is what we are doing here. And here, write agent configure I in the sense, see, if there is a top level, in top level there is a write agent. Inside that there will be some write agents. There may be one or two, more than one write agents are there, and we don't know how many write agents are there, but how many write agents are there, for that we need to create, okay? We need to create a space, we need to create that agent, okay? So for that, we are using this 38th line, like M write agent config, I in the sense, we don't know how many agents are there, so I will take care of that. And we are creating that component using this create keyword, okay? Then as usual, it is going to mention like it is active or passive, like that the same information will be here, okay? And here we are initializing like the configure number of write agent is equal to the actual number of write agent, and the configure number of read agent is the actual number of read agent. What we are doing here is we are mentioning these actual agents to this configuration one, okay? Because then only it can hold that TB, okay? We are telling that TB means test bench. We are telling to the test bench like we are having this many write agent, we are having this many read agent, like that, okay? Then only in the top layer, if we do further process, it will know, then we can do there itself, in the top layer itself, okay? Then see, as I told you, the environment will be built inside the, see, inside the test, okay? See, environment is building here, okay? So what we are doing in this line from 65th to 69th line is we are giving the information of the agent to the environment, okay? So here mtb config means, see here, mtb config means you no need to worry, it is of environment configuration, okay? So see here, see here, what is 87 in the test bench, yeah, here, see, we are creating that environment, okay, configuration. Here we are creating, and as I told you, if there is a write agent, we will create, okay? We will make some space for that write agent. We don't know how many agents are there inside that write agents. Inside the write agent, there may be number of write agents, okay? So for that, we need some space. That's why we are allocating here, okay, using new keyword, okay? And it is also a dynamic, okay? So new in the sense, see, actually you are all familiar with the dynamic, no? While initializing, we will initialize with the empty square bracket, and then while using, we use new keyword and we assign some space, a number of how many number of space we need, how many number of elements are there in the array, like that, okay? So that is what they are using. It is dynamic array. Just simply when it comes to simple terms, it is just a dynamic array. They are utilizing that concept in this, okay? Then see here, there's a base test. Here it is nothing, you no need to confuse. See, this is our router base test class, which is extended from UVM test, and this router base test class have one more class. This router test one is extended from that router base test, okay? So it is of testing, okay? For testing purpose it is. See here, we are creating the sequence, and I told you, no, as we told, you can refer the architecture as well, okay? The sequence is created in the test block, okay? It is what the architecture, if you refer the architecture, you can refer the sequence is always present in the test block, okay? V sequence in the sense virtual sequence. So we are creating the virtual sequence inside the test, and when we go into the virtual sequence, we have our actual sequence. See, in the virtual sequence, we are creating our, see here, this line 118 to 121, we are creating the actual sequence, okay? And that virtual sequence is created inside the test, okay? See here, we are creating the sequence, and we will start the sequence. See, inside that environment, we have sequencer, no, virtual sequencer, no? So this is what the handshaking mechanism is, okay? So that virtual will start, and it will be transmitted, that transaction will be given to the sequencer, and that sequencer will be that transaction will be taken by the sequencer and will be given to the driver, okay? That is what this line, okay? And rise object drop off section means it should wait, okay, that transaction till the completion, it should wait for some time, okay. So for that waiting time, it is called as rise objection, and after completion, it will be go to the drop objection, okay. This mainly comes under the run phase, okay. In run phase only we use this rise objection and drop objection, okay. So whenever our transaction process is started in the run phase, okay, this rise objection will come, and until it is finished, this drop objection will be there, okay. It will wait for some time throughout the completion, because there will be many transaction, no. So we need to wait to complete all the transaction, because when it comes to run phase, there may be different many run phases are there, no, many for different components there is a run phase. So all the run phase should be run. So till that night we need to wait for that phase rise objection. So after completing all the run phase operations of the all components, okay, if all components completed the run phase, then drop objection will be signaled, okay, then drop objection will be used, okay. So same for this router test 2, okay. Why we are router? I told you, no, we may have one sequence or we may have two sequence, like that I told you, no. That is what they are using here. See, here they are creating a sequence, okay. So as of our knowledge, here they are creating two sequence, okay. So the two sequence will be used here, okay. Based on our needs, it will be used, because we have three destinations, no. So it will be used accordingly, okay. So at last, here we have test bench, okay. Test bench is actually very easy, okay. We will inherit all the blocks, okay. See, we are including all the blocks which we are used here, and see in this design we are using every blocks, okay, here, and we will include the package, import the package and all, and then see here we are creating a clock, okay, and instantiate the interfaces, okay. Here we are instantiating the interfaces, and here we have clock, and this is the important thing, okay, that connection, we are connecting it with the DUT through physical interface. That is important. When it comes to class, we use virtual interface, but since this module is static in nature, okay, so this module top is static in nature, so we use actual physical interface to interact with the DUT and test bench, okay. So we are connecting the physical interface here, and we are connecting the signals through this physical interface. See, clock, reset, packet valid, data, error, busy, and see, read enable 1, 2, 3, and data out signals and valid signals, all we are connecting with this virtual, okay. Actually it is not virtual interface, actual physical interface, okay. Then here in the initialize block, set the virtual interface instances, okay. We will just set, that is, we need to mention, no, which virtual interface name and where that virtual interface is coming from. We need to set that information, no. For that we are using, and we are just running the test. See, we created the sequence test inside the test block, okay, and we are running those sequences here, okay, with the help of that test block. See, notice this test. Here we have two test cases, that is, we have two sequences. This is where it is. See, this is number 1, and this one is number 2, where it is. This is number 2, okay. And where we are going to run this means, see here, run test, okay. It will run the router test 1 and router test 2, okay. This is what the top layer is, okay. And these are all connections, okay. These connections come under a router test package, and we include that, import that router test package in our test bench, okay. And the UVM package we usually use, okay. Then only we can include all the UVM packages, okay. And we will include the designs as well, okay. This is what the test bench is, okay. As of now, is there a doubt? Actually, a doubt in the sense, logically you are clear, no? Logical, what logic there is, and why we use virtual sequence, and in that there are particular logic, no, some if conditions and all. So that and all understand for you, no? Is there any doubts in that particularly? Coding means you need to go through, okay. There are some procedures and there is you need to go through one time or two time. If you go through means it will be easy for you as well. Okay. So is it clear for you as of now?
Like here, write agent and write agent config is there, no?
Yeah, right agent.
And write agent config is there. So in config, what you mentioned, one show the code like
Yeah, 1 second please. The right agent configuration is there.
config, that one.
Yes. Actually, what we
Like
are going to mention here is, here we are going to mention the count, how many, because inside the agent we have monitor and driver. So we need the count from driver, how many transactions are sent. So from receiver, from monitor, how many transactions are received. So for that, we are using this configuration. We are using this inside our configuration, this, and we are mentioning whether our that is whether our agent is passive or active. So these information will comes under this configuration, and we can use this configuration inside the agent by getting that configuration. See here, UVM config DB, and we are mentioning that router write agent config, and we will get that. We can get the access, and then we can use it. We can see here they will mention some count now here. So that and all, how it is possible means we can get the access and we can make it for our purpose. That is what that config is of. We just configure what it is of. We can configure inside the write agent also, but for our clarity and clearance, we are configuring it in the separate block. Okay. Or something else doubt.
Yeah, that one only. And one more doubt. We are in the virtual sequence and sequencer is created now. So
Yeah.
the reason of this, like there is a randomized bit will present in sequence, and then like and again you write the right sequence and read sequence there also in the code.
Mhm.
So
Yes.
like the reason
In
of
virtual
this too is
sequencer.
to create. I'm asking you like this reason I don't understand why what is like to create a virtual sequence and virtual sequencer in the code and again create write and read sequence in the code.
Yeah, actually, what it means, see, we have actually in our design, we may have, actually, I told you, no, we may have 3 to 4 agents. Okay. So, because we have 3 destinations and we have one source, so we, according to that, we will have more than one agent. So, each agent will have a sequencer, its own sequencer. Okay. So, we need a common place to store all the sequencer. Okay. So that's why we are using virtual sequencer, and inside that virtual sequencer, we need to allocate the space for the actual sequencer. No, okay, we are getting that virtual sequence. Actually, we are getting the actual sequence and putting it into a virtual sequence. But to write that actual sequence into that virtual sequence, we need some space. No, for that we are creating here. See, this will make some space. And why in that sequence? Why we use create in the sense? We are creating inside this virtual sequence, and in that virtual sequence will be created into the test. Okay, if there is no virtual sequence, usually what we do according to the architecture, we create our sequence in the test block only. But since we have virtual sequence, inside the virtual sequence we are creating all our sequences, and that virtual sequence is created in the test. Okay, this is for our easy accessibility. That is why we are using virtual sequence and sequencer. If I am checking coming here and I check means I can check no. Oh, these are all sequences here, like that. In, see, it is from our point of view, it is very simple. But when it comes to industry standard, there is if there is a common platform to access all the sequence, it will be easy for the testers as well. That's why we are using virtual sequence and virtual sequencer concept. That is what your doubt of?
Yes, like so we are creating for like to you easy access to other sequence and sequencer, you know, to get the access of
Hmm.
this. So virtual sequence is okay. Like sequencer is the like what to say is a connecting block between like driver and sequence, no sequencer.
Yeah, yeah.
So
But here
this
also we are having many sequences. No, sequencer also there are 4 to 5 sequencers may be there, no? So for that purpose, we are creating a virtual sequence and we are including all the sequencer into a single block. That is what, for our easy accessibility. That is what here. Okay, any other doubts? Actually, you need to go through this code once again. See, to be frank, for me also, I need to go through, but I have some previously I go through this, no, so I can explain this. And it is first time means you need to go through 1 to 2 times. Okay, so if you go through means it will be easy for you. But it is logical. We can understand the logic and we can understand the actual characteristic of the block. But inside that, there are many procedures, there are many words, assignments are there that will be understand once we go through it deeply only. Okay. So I think they have shared the code, I think. So I will tell them to share the code. If not yet shared, you can go through. And if that time, if there is any doubts or any queries, if you have any that, we can solve it, no problem.
In like FSM code that they explain, I have some doubt in that. Can you come show that
Yeah, sure.
like FSM
Yeah, here only.
structure, like
This one, now. Hello.
no, not no, like not this one. I'm saying in like a block diagram.
Block diagram, huh?
PPT.
Okay, wait. Okay, 1 second.
Yes.
Yeah, here it is. Yeah, here it is. Yeah. In that,
Yes, like it's loading actually. Okay.
where?
Yeah, yeah, it came actually some lazy. It's not loading properly. So, now it's okay. So here,
Now it is
after
clear, huh?
loop that, yeah, yeah, clear. I have one doubt only. Like once after the loading the data, when it's again like data load complete. Now it's come to FIFO full state. And then you said ki we need to wait for some time to get the FIFO to empty. Like how it's possible to get it to again empty from load data
Yeah.
to FIFO full
Mm-hmm.
state. That part not understood.
How it
And then
is?
load after full.
Yeah. Low? Yeah, that one I will explain. Then where? Anything?
And that one only, that actually made out ki like this part complete, that this last part not understood.
Okay. See here. Actually, we have FIFO, no? So let's consider FIFO have some, in our case, it have 8 space. Okay. For our example, I'm telling. See, in our example, how many? 1, 2, 3, 4, 5, 6, 7, 8 spaces are there. Okay. And here is our destination. Okay. So here our packets will come. Okay. And it will be go to this destination. So here is our data. Let's consider like some any packet or data, anything. Okay. So if our FIFO is full, okay. So we should wait for some time. That is, see here, if our FIFO is full, okay. Why we are waiting? Who will make that wait means our FSM will wait. See here. Yeah, inside that our FSM will make it wait. It will stop the signal actually. Okay. So what happens is, see, if we write one data to this destination, we will have space of one data. Okay. So in that space, we can clear. So in that time, if we write one data to the actual destination, we get some space, no? So at that time, this FIFO will become not full. Okay, this not full condition will happen. At that time, this FIFO full state will be cleared and it will move to this load after full. Then what happen is we will load one more data. Then it will follows. We will write one data. We will load one data. Or if it takes some time and we load 3 data, then we have 3 spaces like that. We will write and we will load one thing. Like that it happens. Clear or some you need some clarity in it?
Yeah, clear. initially I'm thinking कि full FIFO it is going to destination, but like not one by one bit it will go. Like,
Yeah, yeah.
where
Actually,
the
our router, once that FIFO, see, in each FIFO, here, wait here, where it is. Yeah, in each FIFO, there is a signal, no? FIFO full. Once the signal come, our synchronizer will take that signal and it will give to that FSM. So our FSM block, no, it will stop, it will hold some time. It will make that FIFO full, whichever FIFO is full, the transaction will be stopped there. Okay. Then FSM will start doing its process. It will go to the next destinations and it will do its process. But whenever that particularly one FIFO gets some space, no, then we will start loading the next data. Once after it is clearing, we will load our data furtherly. That is why I told in the coding, in one part we have 14 packets, no? So in that case, what happen is, if our capacity is 5, it will just load the 5 and it will send to the destination. So whenever we are getting some free spaces, we will load the our data in the FIFO. Okay, we will write one thing in the, we will write one data into the destination and we will load one data into the FIFO. That is how it happens. Any, this is what clear now, or
yeah,
still any doubts?
yes, clear.
Okay. Okay, is there any other doubts for others? Is there any doubts? Okay, 2-0. Okay. Okay, then you can go through the session and I will tell them to share the coding. I don't know whether it is they shared or not. I don't know. I will share anything. I will share, and there will be recording sessions. You can go through, and if there is any doubt, you can ask me. Okay. So as of now, if there is any doubt, you can ask or you can leave. Thank you.